Hi there and welcome back to Triplicate and number 10 in this series of digital synthesis tutorials. And in this one we're going to look at what, if anything, we do to oscillators and LFOs when a new note is played. And first we're going to look at what we do with oscillators. Okay, up to now, when we've started a new note, we've just set the pitch of the oscillator to that note and just left the oscillator to run, to oscillate, I guess. But in some circumstances, that can have the effect I'm about to play you. Okay, there we just have a single note repeated, and you can hopefully hear that the start of the note sounds different, and because it's exactly synced to the sample rate, it goes in a series of 3 notes. I'll play it again and just listen to the very start of the note. Okay, it's quite a small effect, but the human ear and brain are very good at picking up on these slight changes like that. And if you produce music, also pretty good at getting annoyed by something that's just not quite as you want it. Okay, so here I have the same in the top track as we look at it, but in the bottom track I've output just the oscillator. There's no filter on this, and you can see the problem is that the new note, the oscillator, starts there on the first note, there on the second note, and there on the third note, and that change of starting point on the wave in the new note is enough to create the small change in sound that we hear. And I'd point out at this stage, this only actually occurs on low frequencies and short attacks on the amplitude envelope. However, we shall press on and find a solution to this problem. So how do we fix this problem? Well, the solution is actually very simple. We simply restart the oscillator phase at 0 when the note starts. However, this sudden change of phase of the oscillator can suddenly change the output of the oscillator, which can cause a click in the audio, which just adds another problem. Let's have a look at this. Okay, so here we have another little synthesizer sequence of very, very little musical merit, which I will play you. Okay, and you know there you really can't hear the problem. You can't hear the fact that the start of each note sounds very slightly different. However, we're just using it to investigate the problem here. Okay, and again here on the lower channel we just have the oscillator output, and looking at the 2 lower pitched notes, the first one starts with the oscillator waveform here, and the second one starts with the oscillator waveform here. However, if we now go to look at the whole of the waveform in Spectral View, okay, we're looking at the bottom again, because if the oscillator's well behaved spectrally, so will the output of the filter, and we can see there is no nasty spikes appearing above the upper frequency of the oscillator. Okay, now when it starts a new note, We call the oscillator reset function, which just sets the oscillator phase to 0. So that's pretty simple. And if we look at the waveform again the top trace is with the filter and the bottom without the filter. You could see here the new note starts. Without the reset, the waveform would carry on down from this point only at a steeper angle like that, where it actually goes back to 0 and starts a new waveform there. And if we go to look at the whole of that in Spectral View, oh dear, we can see here at the start of every note, because of that sudden change of phase, therefore the sudden change of oscillator output, we're getting a nasty spike all the way up the frequency spectrum, which we've spent the past 9 tutorials trying to avoid. So we are now going to have to try and think of a way of stopping that happening. Okay, let's say we're plucking a string, for instance, in a bass guitar, and here we have, for demonstration purposes, a real piece of green string. So we get what we're trying to achieve here, because this is exaggerated for your benefit, but we are always releasing the string from the same point, so the note will start with the phases all the same. It's slightly more complicated in a real stringed instrument, but basically that is the situation. So we let go of the string and we see that, yeah, vibrates nicely. And if it's still vibrating and we play the next note, we put our finger on the string to pull it back, and because our finger is soft, that damps the string, so by the time we've pulled it back to that point, it's stopped sounding. So we want to do something similar to that in our synthesizer. We want to damp the existing sound before we start the new one, and if we flip the phase back to the start of the waveform while it's not sounding, then we won't get a nasty click. So let's see how we manage to do that. Okay, so here's what normally happens. We have 2 envelopes here, and this is the point we get a new note, and we've got a very fast attack in this case. So the envelope just goes into the attack phase and up to its maximum from wherever it was. So what happens when we want to implement damping? Okay, so here it is, and you can see envelope 1 at the top has the damping on it, and envelope 2 doesn't have any damping. It just does what it would normally do. Now if we zoom in here, let's have a look at this. That's good enough. So what happens is that we get the note on message here, and this puts envelope 1 into damping mode, and doesn't do anything else, doesn't restart the note, change the pitch, anything. And you can see envelope 2, and if I put the cursor here, there we go. So envelope 2 just continues as it was at the start of the damping phase, and the damping, I've just implemented it as a linear ramp down to 0. That seems to be okay. If we were going to be pedantic about it, we should say we should probably use some kind of a curve, but we're going with linear. So when it gets down to 0 here, this is when it resets the oscillator phases and restarts both envelopes. So there is actually a delay between receiving the note on here and the note actually starting here.
but we can make this damping phase quite short. In this case it is about 2 milliseconds, and in general anything below 5 milliseconds we won't notice the delay. Okay, so here we have the case we had with no oscillator syncing. Let's look at the bottom trace, which is without the filter. So we can see here, this is where the note on starts and this is the attack. So although the phase stays the same, the output increases a bit with the attack of the envelope. Okay, let's go back to the situation where we just reset the oscillator. So that's that one. Okay, we can see here the wave here is still going down, and we suddenly set it to 0, and this is 0 phase for the sawtooth waveform, so it comes up very quickly with the ramp, and that very quick rise will potentially make a nasty click. So let's look at our final situation with our damping. So here we start the damping, so although the waveform is still going down, the damping is dropping. The output value to 0 reaches 0 here. The waveform restarts, i.e. to that point, and comes up here with the envelope, and we get no nasty level changes which could potentially cause clicks. So if we look at the whole waveform here in Spectral View, we can see there are no huge nasty clicks, no sort of broad spectrum noise when the note starts. So I think we've achieved what we wanted to achieve. Okay, so let's go back to our original wave, and here we have it with our damping and wave syncing implemented. So let's play this. And it sounds, each note sounds the same, so we've cured our problem. Also, we can implement a very, very sharp attack using this system. As you hear, is a click at the start, which you can back the attack off or drop the filter cut off if that's too harsh. So let's just for a final comparison compare it with our original. And our oscillator sync version again. Okay, that's sort of quite a subtle feature, which I guess if you were developing a synthesizer you might not want to bother implementing, but I've implemented it because I found it necessary. So I've explained how it works, and whether you use it is up to you. Okay, so now let's move on to LFO syncing to note on. Actually, there are two issues here we're going to look at together. The first is whether we want the LFO to restart when we play a note, which can be a useful effect, and also be a useful effect if it doesn't. And secondly, if we're playing polyphonically, do we want the LFOs to be synchronized to each other and all the notes on a part, or do we want them to be arbitrary relative to each other? Now here we're looking at the manual to the to my VSTI synthesizer, the pulse saw, where I sort of implemented both these as 4 options, and I've implemented the same on the PC test code, and I'm sure there are other things you can do with LFOs synchronizing, but this is just what I'm going to show you for now. Okay, so all these, I've just got one LFO going here, but all the arguments apply equally to both LFOs, so just bear that in mind. And first up, we're going to look at what I've called master mode, where all the LFOs are synchronized together, all to a common master as I've described it here, and free run, that is, they don't reset their waveform when any note is played. Now, to test all these, I have written a little test sequence, and with no LFO on at all, that sounds like this. Okay, that's the same twice because I'm going to, as you will hear, use 2 different LFO frequencies for each effect. So with the master mode, it sounds like this. Okay, so let's go back to here. Now let's look at the other option, which is the 4th, and why I've put them in this order I don't know, where the LFOs are not synchronized to the notes. The note doesn't reset the LFO phase, but all the LFOs are randomly phased relative to each other. Here I've actually set them equally apart, but they could be randomly set apart, or the speeds could all be made slightly different so they drift relative to each other, but I've just tried it this one way for now, so let's see what that's like. Okay, and the third option is called sync to note. So every time you play a note, that voice's LFO phase is restarted. And that one sounds like this. Okay, and I think that's rather a nice effect. I like that one. So finally we have sync to first. Here, if there's no note played, the first note that is then played, all the LFOs phases are restarted, and then free run for all the time notes are held down until all the notes are released. And that one sounds like this. Okay, that's a quick tour around LFO syncing and synchronising. As I say, as I implemented in the Pulsar. I mean, there's loads of other stuff that can be done, and I'll leave you to think up some new and interesting ideas.
Okay, well that's it for this look at synchronising oscillators and LFO to notes. As usual, all the sound files can be downloaded if you want to hear them properly rather than after YouTube's sound processing. Similarly, all the code you can download, and if there's any questions you have about this video, please don't hesitate to contact me. And next time we will be looking at the filter again, and most importantly we'll be looking to see if we can make it warm. So that's it for this video. So it's a goodbye from Triplicate, home of interesting electronics. Goodbye.